All right, welcome to Polar Graphs lesson from Edgenuity Pre-Calculus. These are 10 practice questions that I'll be going over. Hopefully you've already watched the videos and done the instructional practice there. So I'll go ahead and get started. We'll probably get through about 5 on this video, and then I'll make another video for the second half. On this question, it asks us to find the rectangular coordinates of the point -3, comma 1/2 pi. And in polar coordinates, the two coordinates are the radius and the angle measure theta from the standard position. A couple of things we're going to be using on most of these problems is the relationship between x, r, and theta, as well as the relationship between y, r, and theta. Working both forwards and backwards, whether we want to get given a couple of rectangular coordinates coming up with the polar coordinates, or giving polar coordinates coming up with the rectangular coordinates. If I were you, I'd write these down, especially whenever you do the quizzes, so that you'll be able to have them handy if you don't have them written down. We are going to use these on most of the other problems. I went ahead and copied and pasted it on most of the other problems. All right, so now that I know that, all I have to do to get my x and y coordinate is, one, plot the point, which we could do pretty easily, or two, use these conversions right here, plugging in r and theta to get the x value and the y value. The easiest way, though, would be to graph it. If you have a rectangular graph drawn and you use the polar coordinates, you go out to -3 from the standard position, so -3, and then rotate it 1/2 pi. It's going to be down here at 0, -3. So should be answer choice A. Let's check using the equations just to make sure. So x equals r cosine theta. If we plug in -3 and our theta is 1/2 pi, we can plug that in our calculator, -3 cosine of 1/2 pi. We do get 0. And for our y value, we can do the same thing. R is -3, and theta is 1/2 pi, so -3. Sine of 1/2 pi. Make sure you're in radian mode for these measurements. And we do get -3, so definitely that is what we get. All right, for the second one, it says find the rectangular coordinates for the point. Looks like the exact same thing we just did. We need to convert these. This one a little bit uglier because of where this is at in the degree measurement. It doesn't happen to land exactly on a grid line. We could get an idea though. If you go out to square root of 3, so square root of 3, hopefully you guys are familiar from the trig section that we did, but square root of 3 does equal about 1.73. If you go out to about 1.73, let's say, and then rotate 1/6 pi, that's only going to be in the first quadrant because this is 1/2 pi. So 1/6 pi, not going to be very far at all. So somewhere around here, I guess. So I think my coordinates should be in the first quadrant. Nothing's negative over there, but doesn't help us a whole lot because all of these points are in the first quadrant. So let's just go ahead and plug in x equals r cosine theta, see what we get. And for the y value, we'll do the same thing. Y equals r sine of theta. We'll just plug these in and see what we get for both of them. So for x, the r is square root of 3. And plug that in our calculator. Let's see what we get. Square root of 3 times cosine of pi over 6. Be 1.5, so 3/2. And for our y value, square root of 3 times sine of pi over 6. We should end up getting y value at pi over 6 should be 1/2, so square root of 3 over 2. Yeah, I guess I didn't even need a calculator for that. All right, so my x value is 3/2. My y value is square root of 3 over 2. Should be answer choice B on that one. All right, on number 3, it says plot this point. Some people like to plot the radius first and then rotate it because it goes in order there. If you plot the radius first and then rotate for your radian or radius measure and then your angle measure. I like to do the angle measure and then decide how far I'm going to go out. We'll look at both of these here. So which one of these is this, A or B? Well, if you started with the radius measure and went to -2, oops, I guess I'll just do it down here. Go to -2 and then rotate pi over 4. That should be pi over 4 in the positive direction. So we know the positive direction goes this way. Make sure we're rotating this way. So we should go down here, 1/4 pi. Remember, every quadrant is 1/2 pi, so should be exactly in the middle right there if we did that. So that's not plotted correctly. Looks like B is plotted correctly. I would have rotated pi over 4 first, go pi over 4, and then instead of going in the positive direction, I would just go in the negative direction there. This is the positive direction of pi over 4. This is the negative direction of pi over 4. So a little bit easier way is decide where you want to go. I want to stop right here, but I don't want to go in the positive direction. I wanted to go in the negative direction too. So it should be answer choice B on that one. As I mentioned, some people do radius and then angle measure. Some people do angle measure then radius. Doesn't really matter, but either way, make sure you go in the negative direction of the radius, but the positive direction of the angle. All right, on question 4, says find all the polar coordinates of this one if the point equals 1 negative pi over 6. So r theta, we know r equals, r equals 1. And theta equals negative pi over 6. So if you wanted to plot this, you could, just to get it real quick, get an idea of where it's at. Radius is 1, angle is negative pi over 6, so go out to 1. Go in the negative direction, pi over 6 should be right around here, rotated pi over 6. So negative 30 degrees we got there. All right. There's a lot of ways to plot this point right here. We know that from here, the way that we could represent more of these, right here we have this one, is any full rotation around 360 degrees or 2 pi. One full rotation in degrees or radians. So from the point that we're given, 1 negative pi over 6, we know that all we'd have to do is add a full rotation. So any of them that say that are a possibility for some answers. So it looks like A, B, and D all make sense on that one. So I don't think C is going to be it. I don't necessarily know. We're crossing that out, but A, B, and D all have those answers on there. This right here, N, this integer, just means it is going to be representing an integer that could be, 1, so it's 1 full rotation. If it was 2, 4 pi, that'd be 2 full rotations. If N was a 3, it'd be 6, so 6 pi rotations. So just means any whole number multiplied by 2 pi. All right, so now that we had that point on there, how else could we get that? Well, you could have started with a negative measurement, like -1, and rotated in the negative direction here. Or you could have rotated in the positive direction to get all the way to that point. So how far would I have had to rotate if my radius was negative to begin with to get to my point, 1 negative pi over 6, so this point right here. Well, another way to do that is with a negative radius. You could have rotated positive, not quite 1/2 of a full rotation, so not quite 1 pi. That's actually 5/6 pi. So this angle here that we would have rotated would have been positive 5/6 pi. Because if you start off with a radius of -1, we rotate this direction almost 1/2 full rotation, so almost 1 pi to that same point. So another way to do that would have a radius of -1, a rotation of 5 pi over 6. It's another way to do that. And I don't see that one on there. So how is that, I guess, not one of our answer choices? Well, let's look at it this way and see what they did from some of their answer choices and see if any of these work. All right, so let's start with this one right here. We already know this one works. Let's look at this one. So -1, negative pi over 6. So -1 rotated negative pi over 6 ends over here. But if we take that, we're not quite done yet. We have to add 2n plus 1 pi. So let's pretend for a second this was a 0. We add 1 pi, we add 1/2 of a rotation. So we add 1/2 of a rotation and end up down here. If this was a 1 right here, it'd be 3n, so we'd go 1, 2, 3 pi. We'd still end up right here. So it's basically saying add a odd number of pi. So add 1 pi, or 3 pi, or 5 pi. So this one actually does work to get that exact same point. If you start off with a -1, rotate negative pi over 6, you're right here, and then add an odd number of pi's, that means we're going back this way. 1 pi would end up right here at the same point we want it to be at. 2 pi, 3 pi would be back at the same point, any odd number of pi's. So 2n plus 1 just represents an odd number. If n is an integer, you take basically 2 times an integer, you get an even number, add 1, you get an odd number, and you'll end up at the same point. All right, question 5. Determine 2 pairs of polar coordinates for 4, 4 when x or theta is between 0 and 360. So the point 4, 4 is right here. I know if I want to get a radius and a angle measure, hopefully we know 45 degrees is there, and if you did Pythagorean theorem, we do end up getting 4 squared plus 4 squared equals r squared, square root of 16 plus 16 equals r, square root of 32 equals r. Looks like they simplified it, so square root of 16, square root of 2, 4 root 2. So r equals 4 root 2.